me change the this one. So idea of threading is when instead of creating a number of processes, because the process structure require the very strict the data structure, like including text and the data and the heap and the stack area. But when you create the parallel process, a lot of such a data structure can be shared. So why not share the, instead of creating entire the processes, we are going to share as much as possible. Then the process specific, in other words, the thread specific, the data structure will be created. That is called the thread. So because of such a characteristic, sometimes we call the So we call such a creating process is called a heavyweight processor. On the other hand, such a thread is called a lightweight processor. Then such a lightweight processor, the thread has its own information like the program counter, register information, thread specific the data, and so on. So that is the in terms of a PCB, you are able to see such the information.
So the PCB is the heavyweight?
Yeah, PCB is the data structure to keep the information about the entire process. Then when you create the thread, so you don't have to keep all such information. Instead, like the thread specific information will be managed. Okay. So that is the thread. So this is an example of the POSIX thread. So we have seen the thread example. One is the P thread. P thread is for the Unix or the Linux system. So, but P thread is kind of POSIX thread is kind of the standard. So based on that specification standard, each operating system implement their own thread library. So this is the example of the P thread, and also yes, that is the P thread. Then this is the example of the POSIX P thread. So you are able to create your thread using the P thread underscore create. Then this learner is the task that you are going to run in parallel. And such a created thread will be joined to your main process using the P thread underscore join. Then this is the learner. In other words, the task that you are going to run in parallel. So in this example, this is the summation of the value, just a simple example. So you are able to add your own parallel task that can be run in the thread. It doesn't have to be the same task. If you design the thread specific algorithm, it's totally fine. But at that time, you need to create a different runner. So to assign this runner to the thread. Okay, so this runner will be specified as an augment of the P thread create. So then you can create as many as the thread as possible. So like in this case, you can run the 10 thread. So 10 thread will be joined into the process. So that is the example of the P thread. Windows also provide the thread library. Okay, so it's the same idea. So this is the summation is your thread specific task running in parallel. So then this is the C program example based on the Win32 API the thread. Okay, So you can see the name of the such a system library is create thread, and the thread specific task summation will be specified as an argument of that. So that is actually defined over here. Okay, and you can the syntax may be different, but their architecture, multi-threading architecture is a server. The architecture is the same thing. So as we have seen before, we have the multi-thread server, the client or user request, then the create and join. And this thread server is waiting for another request like that. So that is the example of Windows Java. Probably a lot of you already practice Java thread in your program, the programming class. So at that time, you need to create object, the runnable object. This runnable will be specified in your thread, the object. So this is creating the instantiating your thread. Okay, and you can this worker create the thread and join to your process. By the way, so we discussed a lot the Java actually basically use thread whenever you run any application. So this kind of example, the Windows or the P thread or the Java thread. So these examples are called explicitly the creating the thread. It's a user thread. Explicit the Java the explicit the thread. So sometimes you may not realize whether your application use thread, like for example Java. So if you run any Java application, implicitly the thread is created. It's called nowadays more and more the implicit the thread will be used. So who is in charge of such an implicit thread? The compiler. Basically know such a thread. And or your program language is a compiler also, or server side. So nowadays, instead of using user-specific the thread, we are using more and more the implicit the thread. So in case of Java, it's called the Java executor, the framework to use the thread. Okay. So at this time, you can specify the thread specific the task as a runnable. Okay. You can give the command or you can give the object that you create. So this is an example of the Java executor framework. So this time it's the same task we are going to sum using the thread. It's a summation that will be defined over here. Then specify here. So you can summation. The object will be specified in the executable the thread. Okay. So nowadays the thread is better in terms of the research utilization. So more and more the program language use implicitly use the thread. This is called the implicit threading. So you may not realize as a user. Okay. So to do that, there exists a different method to support such a the implicit threading, like the thread pool, fork join, OpenMP, Grand Central Dispatch, inter-threading building blocks. So we will see each of them. Okay. So first one is the thread pool. So thread pool means, so I had for example student pool for teaching assistant. So which means, so even though right now I'm not using or I'm not hiring the student assistant, but before in advance, I'm going to call the student, anyone who are interested in the student assistant, then I select such a number of students as a pool. It's a candidate. So they are not the assistants right now, eventually will be selected. So the benefit, I don't have to waste time to interview and find the assistant. Instead, so whenever I need, I can find the one from the pool. So similarly, the thread, the main reason why we are using the thread is efficiency and save the resource. So to save the resource, why not creating the thread first? Which means we don't know what kind of task will be run on that thread, but the thread itself is data structure. In other words, it's a memory resource. So even using thread, when you create the thread, this is a process on the memory. Even though you are creating the thread, number of thread, it still requires memory resource, which means it needs I/O. So if you create 100 thread for this process, it takes a time. So why not create the thread? It's kind of empty thread. Thread 1, thread 2, thread 3. Okay, on the memory. Then whenever process create the thread, then just refer the address, reference. Okay? Then the thread specific, the task, like if you are doing the summation will be the assigned. Or if you have the thread specific, the command will be exec. And so this is called the thread pool. So advantage of using such a thread pool, definitely it's a faster, not huge faster, but it's faster than the creating the new thread. Okay, such a technique can be used a lot. Nowadays the memory size is much bigger comparing to the 10 years before or 20 years before, and also the getting cheaper. So why not the load as many programs as possible as a process on the memory. Then later when we execute, right now we don't use that program, but it will be used so we can save the time. So for example, Windows, the people complain, it takes a time to boot the Windows. When you start the Windows operating system, it takes a time. So Microsoft would like to put as many, because they put as many processes as possible in the memory. So it takes a time to start. So later they take out some of the process, but still a lot comparing to the Unix or the Linux system. Because they want to make the efficiency on the entire operating system, but because of that, during the booting time, it takes a lot more time. So that's the idea of the pool. So you can allow the number of threads, okay, the application then can use such a thread pool. So in case of Java, the Java executor has the thread for new fixed thread for the object you can use. Then you can specify the size of the pool. Then you can create the thread from the thread pool. Okay, this is an example of using the Java thread pool. So for example here, it's the new cache the thread pool is created, instantiate. It's a memory allocation. Then you are able to. So how many tasks? Like the 10, then 10 the thread will be created. After done, then the shutdown. Okay, that's the one way to use the thread pool. So in place the thread. The next one is a fork join parallelism. So idea is really simple. So for example, so you learned about the divide and conquer in your algorithm class, right? What is the idea of divide and conquer?
To take on things in portions,
Mm-hmm.
so cut it up, it'll be easier to handle piece
Yes.
by piece.
Right? So when you fight, so you cannot fight the 1 to 10.
Yeah.
So divide 1 to 5. Still is a bit. So half the 1 to 2. I said still 1 to 1. Then if I win, then the next, so on. So same thing in the computer system. If we can, so sometimes here the problem or the task is really huge. Like for example, suppose that you are going to sum 1 through 10 to the power of 1,000, for example. And it takes a really long time, even we cannot imagine 10 to the power of 1,000. So our idea is, we don't know how much big the task is. So you are going to specify the threshold. So my computer, my thread can take care of up to the 10,000. So summation of the 10,000 is my threshold. Then we can the reasonable the efficiency to add up the 10,000 number. So start this job. So it's 10 to the definitely much bigger than our threshold. Divide it into 2. Okay. So left and right. So it's a half of this, right? Check whether it's less than threshold. It's still big. Divide. Good job. Check each of them. It's still big. Divide in the half. Okay. Then once there is less than threshold value, so we run the thread for this test. Then report to the parent who divide this job. And this one also. Right? And everything. Everything finally it will be completed. So this is basically based on the divide and conquer. We are going to divide the job until we are able to manage such the task. Okay, then the combine. So this approach is called we are going to divide. That's called the fork. And once you are done, this is called the join. So this is a fork join, the parallelism approach. That involves what? Recursive. So it actually when the program language implemented this one, they are using the recursive library to implement this. You can do that. It's basically fork and just one step. So you can create such a recursion, then run. So this is the idea of the parallelism using the thread. It's called the fork, the join. So this approach is used a lot actually. So nowadays, the thread support. Does the user program assign anything? No. What you need to do is just a threshold. Then use such a fork join approach. Then implicitly is create a number of threads. Then run your task in parallel. So this is the fork join. The thread. It's also implicit the thread. So you don't have to worry about the coding the recursion. No, it's already the thing. So this is called the fork join, the parallelism. So this is a pseudocode. It's not the programming specific, the code. It's just a pseudocode. As you can see, we are going to start the small enough. That means it's less than the threshold value, or the condition to start. If you remind the class on the recursion, so in data structure class, the recursion should have what? Start condition. Otherwise, it will be forever. So that is a start condition threshold. Otherwise, divide the job into 2. The fork means it's creating the new task. Okay. Then the checker. This one will run the task. This is a task. And this is called the recursion program. Okay, then you remember that the recursion, it's just a simple with the recursion. So then at that time, whenever we create the child, the task, it will create the one thread from the pool and running. Then if the, so return the result, then the going back, so if we illustrate that one, so this is the first task, but if the task is bigger than threshold or not satisfying with the condition, and create the small the child task. Then the same thing, the child task. If this one is done, and return the result, that is called the join. And combine. We are using the similar approach in the big data processing. So if you know about the header, the distributed file system, the map reduce program and the Spark program uses such a the mapper and reduce. So mapper means such a fork, divide the job on each data. Then the return the output and combine. So in case of Java, so Java provides such a fork showing the parallelism. Okay. So you can instantiate the fork join the pool. So it's basically use existing the thread, the pool, so which is called the fork join pool. Then you don't have to implement any recursion here. Just give the parallel task. Then with one, the threshold. Yes, so in this case, so this is the example of the fork join, the parallelism in Java. So you can see the threshold value. In this case, for example, 1,000. So until less than 1,000, it will divide the job. Okay, fork, and create a new thread like that. So the fork join is basically based on the recursive, the programming. So actually, the Java use the recursive, the class. The next one is OpenMP. OpenMP have used a lot. I think maybe 10 years before. Nowadays, I'm not sure. So I didn't pay attention to the distributed and the parallel computing recently. So I didn't see many paper or the real system using the OpenMP. But when I was in the company and also when I was a student, the OpenMP. So library name is OpenMPI. So based on the C or the C++, sometimes the Fortran. So it's API level, the parallel programming, which means if you have your own task, like this part, print F is a parallel task, like the summation or the whatever. This is the algorithm to be run in parallel. Then you're going to run this program with the OpenMP library. Then the OpenMP automatically implicitly divide the job to the number of the node in cluster, then run in parallel. At the time, the OpenMP managed such a thread pool. So OpenMPI is the library to implement such the C or C++ based parallel programming. This OpenMPI uses also thread pool. So this part will be your task running in parallel based on the thread pool. So then what about the macOS? macOS also provides such an implicit thread, the programming, which is called the Grand Central Dispatch. So in the Apple, the family, the programming, so you probably know the Objective-C language. Nowadays, the name is changed. They have Swift. The Swift programming is actually based on the newer version of the Objective-C, the language. It doesn't matter. I'm familiar with the Objective-C language, but you probably know the Swift languages. So Swift languages support such the parallel programming. in use based on the thread form. That is called the grand central dispatch. So if you want to run the specific task in parallel using the thread, you can use this symbol. Okay, inside the symbol you can put the command like the, for example, if you want to the print in parallel, so like you can use this symbol in parentheses and make the block, then this part will be automatically run in parallel. So using the thread form. So this is called the grand central dispatch. You don't have to do anything, just include that library, then use this symbol block. So there are two types of the grand central dispatch. One is the serial. So serial manage the only, probably this is not the only program requesting the thread using thread form. There might be many the process request. They're like using this symbol in many programs. Even one program may have the several. So whenever this request is received, the OS managed one main queue. This is called the serial. So based on the queue is first in first out, default. So if the request first, this one is first, and run in parallel using the thread, then followed by this, followed by this. So this is a serial. It's called the main queue, whatever the name is. There's one the request the queue. On the other hand, there is a concurrent. Concurrent actually not just one. Sometimes you can take the number of requests at the same time. So that override the order of the default queue, main queue. You can run sometimes you can, based considering the resource, you can run the several requests at the same time. It's a concurrent queue. Intel also support it's a C++ based the implicit threading. So Intel threading building block. So basically it's the similar idea as the grand central dispatch. So if you specify something, so this is your normal, the for loop. Like we are going to run the apply, this one, whatever that is, the for loop how many times? N times, like that. But the Intel, the TBB support something called the parallel for statement. In parallel, this part will be run. So this part will be run in parallel. So like if n is 10, so we are going to run apply 1, apply 2, apply 10, like that in serial. But using the parallel flow, so we can run the 10 apply at the same time. Okay? At that time, it is based on the thread, the implicit thread. So Intel threading block. Okay, so these are the example of the implicit thread. Nowadays, more and more, instead of user-specific thread, that's the reason. Even though we are using a lot the thread, we may not know whether I'm using such a thread. But as a computer science major, I think at least the Java threading, the user, create the user program. So in your own code, why don't you try to create the thread? And then one more thing, if you can create the number of threads, is communicate between the thread and the song. There are a number of issues when you are using thread because it's a minimized version of the processes. So definitely it's different from the data structure used in the processes. The first issue is the fork and exec. So what if you run the system library fork and exec on your thread? Does it work or not? So think about the fork. So fork means copy process, right? So it's copy the process and find the resource and share the data, not the text part, the program, the instruction part. Then when the EXEC system library is called, then you are going to upload your own programming code, then it will be child process. This is the fork and EXEC. What if you fork inside the thread? It's okay. There are two types you can imagine. One is, so you have the main process, then this one create the thread. Let's say that there are two threads here, okay? They're created by the process. If you fork here, your entire process, including thread, can be copied. Okay? Or some of the operating system limit only the thread that is executed, that run the fork. Okay, there are different types of. There's no the general rule. When you run the fork, inside the thread, but the basically two types. One is copy entire the process, or the copy only the thread that run the fork. Okay, so this is the thing you need to consider depending on the library of the system library, operating system. You need to check what kind of option you are going to use. What about the EXEC? Not a big problem. You can download the ls. In case you copy everything, then run execute the ls, the instruction in this thread, or EXEC. Not a problem. So EXEC usually not a big problem, but the fork you should be careful when you run.
Professor?
Yes.
So is there an advantage to using one, like the one that copies both, like all the threads, or the one that just copies the thread?
It depends on your, the requirement. So if the entire process is created, definitely it's a waste of space. However, you can keep the semantic meaning of the fork. The meaning of fork is I'm going to create the exactly same thing as the parents, then find the resource. That is the fork, right? Then you may continue all the status of the parent. Okay? But definitely because you are doing something inside the thread, that fork, that means probably it's a thread specific, not entire. So it depends. So that's the reason there's no general rule or general advantage, but depending on the operating system, mostly you don't need entire the process. When you fork inside the thread, it's mostly the thread specific. Okay? Then also communication. The thread can be communicated each other between among and with the process at the time they are using signal. So signal is the way to inform in the Unix system. So it's called the signal handler. So operating system, if operating system receives such a signal, then the operating system know the signal number that point the address of the memory. That memory has the code, the action to run for specific signal. For example, interrupt signal. So interrupt signal has, for example, most popular the interrupt signal used in the operating system is the divide by zero. What happened divide by zero in computer? It definitely should be error. It's not the error, right? Divide by zero, okay? But in computer, there's no way to keep the output of divide by zero. So you need to stop. You cannot do that. How do you check? in case of the event is divided by 0, then send the signal to the operating system. It's divided by 0. Then the operating system, the handle, such the signal, event, in case of divide by 0, going to memory address 0010. 0010, actually stop, Control C, interrupt signal send back to the program and stop it. So that is kind of the event and signal, then the communicate doing something. So thread uses such a signal in the Unix system and then signal handler. Okay. What if when we terminate the program, so when you terminate the process, so you are going to revoke hold the resource and remove the process list from the process table in your operating system, it will be ended. So that is the termination of the process. What about the thread? So when the thread is completed all their job, that will be done. However, if you sometimes when you want to terminate falsely, to cancel the thread, so you are going to cancel using the signal, or sometimes the thread library has the function to cancel each thread. At that time, there are two types of the cancellation. One is asynchronous cancellation, and another one is the default cancellation. Okay. So, for example, asynchronous cancellation is falsely terminate right away. So even though the thread is running, doing the something job, it's falsely terminated. This is called asynchronous. But as a default, the thread can, even though the main process send the signal to cancel, but the thread itself will be running to complete the job task. So that is the deferred cancellation. So even though you try to cancel, the current running job will be done. So you can select each of them depending on your requirement. So for example, in case of pthread use the cancel the function, library as a function to cancel it. So in case of the Java can use the interim method to cancel the read thread. I think the last time one of the students asked, what if the thread has their own information? So thread also, the thread library allow that each thread can manage the thread specific information, which is called the thread local storage. So in short, it's called TLS. So thread also can keep its own data, its own copy of the data under the storage. That is called the thread local storage. Where? It's in the memory. It's a thread specific area. So data structure will be allocated. Definitely, that's different from the local variable. It's the thread specific information. It's not the local variable. Okay? And also, when we have a number of the thread, increase the thread. So basically, we have the user thread. User thread does not mean explicit thread. It's your application program. And then in the kernel side, a number of threads will be running. So this is the issues when you are using the thread. It's basically in general, it's many to many architecture, which means some of the user thread may use a number of the kernel thread, which means we need to schedule which kernel thread will be used and how many of them are used. So that is a lightweight processes. So this LWP is in charge of to each thread, corner thread will be used, and so sometimes the this is called occur means usually the user thread requests the corner thread, so then find a better one. What if the corner thread need to communicate with the user thread? It's the opposite way. At the time there is the occur event, so you can provide the way to communicate from the corner thread to the local thread. So this is basically based on the occur, the handle in the thread library. So thread library supports such a the reverse way of the communication also. We have seen the number of examples of using the thread, but it's based on the library base. So what about the operating system point of view? So Windows, most of the operating system, general purpose operating system nowadays support such as the thread. So as we have seen just before, the macOS also have not only just the P thread, it provides in-place thread pool, which is called the Grand Central the dispatch, and so on. So this is a quick review of such a thing. So Windows API. So Windows provides such a thread library. Each thread has their thread ID, and as we have seen the register information, and their user mode and the kernel mode, the stack the information, and or any the shared library. In case the Windows is called the DLL, the dynamic linked library. So DLL information will be managed by the Windows thread. So Windows thread has the E thread, it means is user thread. Okay. K thread is a kernel thread. Okay. So Windows support the user thread and the kernel thread. There they are using the many-to-many and the hybrid one also. And the Linux support, it's called the task, but it's a name may be different, but there's a name, it's just the inside the data structure is a thread. But the Linux sometimes use the name of a task. And if you are doing the project one, sometimes you may see the example of using the clone system call. Okay? So clone actually is a combination of the combining the fork and exec. So basically copy the entire task, including thread. So you can use the clone to create the Linux thread. So, but in your the project, so you don't have to. You can just use a fork and exec to create the shell program. Yes.
Clone only applies to Linux, right?
Yes.
And does Windows have like its own version of clone, or?
They use for the creating process, they have the create process. That combine the fork and exec. Then to create the thread, so you need to use the Windows 32 thread library. Okay, that's pretty much the end of the chapter 4 regarding to the thread. So right now you are able to create the process and also including the thread. The next thing is we have a number of processes. They are computing the limited resource. So for example, the most important part is the CPU. Even though you are using the multi-core system and the multi-processor, the system is still limited. Our number of processors easily the 100. In my laptop, when I checked last night, it's 400 something. The number of processors. But my system has 2 or 4 the core, so they are competing. they are lazy to use the CPU resource, then definitely we need to organize such a request. Is called the scheduling. So, and also when we are dealing with the multiple processes or the threaded, they are accessing the data, sharing the data. So as I mentioned, sometimes I confuse with the other class. I think that's the NoSQL database course, the mention about the synchronization problem. When you access the shared data from the multiple processes, so we cannot guarantee the output. So we need to synchronize such a processing for multiple processes. So that is the issue of the synchronization problem. So last of the next few weeks, we are going to talk about how to schedule such a CPU resource for multiple processes and how to organize how to solve the problem of the synchronization and so on. So that will be pretty much the main part of the operating system regarding to the processes. Okay, so we are not going to have the live operating system exercise slot, even though it's scheduled right now. Instead, the BAMC recorded the video for your convenience. So after the class, so it's not just enjoy the time, please. It takes the 10 to 20 minutes, complete your exercise slot. Please using your created virtual machine on GCP, so complete your exercise slot. If there are any homework or assignment on Canvas, please do so. And also for the proof of your exercise slot, you guys can submit the screenshot of your the exercise slot. Vamsi just informed me that he uploaded the video. I'm going to share that video to our class playlist. So that is a YouTube.
The first lab or the second one?
This one, the Vamsi, is the second lab or the second lab, right?
I think the first one is there.
Yeah, it's the second lab. So first one is the GCP we did in the classroom. Then last week we had the first operating system lab. This one is the second, the operating system exercise lab. Okay, so any questions? Let me check. Okay, after class, I'm going to share the link for the OS exercise lab. I'm going to add the link to our class, the YouTube playlist. Okay, so you can keep the only one link, then can watch the exercise lab video. And also our class, the lecture, always available on Canvas using the Zoom. Recently, from tomorrow, the Zoom menu will be changing. Okay, it's better interface. It's the same as the web interface. So I'm going to import all our previous lecture and future lectures, so you may not lose such a data. So you can watch anytime. Okay, if there's no questions, so thanks so much. Please be safe, and then we will see next week, the Monday. Okay, thank you.